That's my question. Okay, let's go a little bit bigger. Let's go to something 40. That's a 1 kilometer asteroid. These are pretty rare, 0.01% chance in 100 years. This is generally accepted that when one of these hits, that is the end of human civilization. It doesn't matter where on Earth it hits. Anywhere on Earth that hits, that's the end of human civilization. Okay, why do we know that? And why are they so sure of that? Because that's big enough when you look in the geologic record. That throws up enough dust and dirt into the upper atmosphere, blankets both hemispheres for a couple of years. You lose growing seasons worldwide for a few years. Anybody here know what our world stockpiles of food are? It's about 2 to 3 months. Okay? So if you lose growing seasons worldwide for, call it 3 years, what happens? You run out of food in 2 months. What happens for the remaining 3 years? Okay, whatever it isn't good, all right? You don't want to live in that world. That's Mad Max or something like that. Yeah, exactly. It's people. So the odds of that are about the same as pretty close. I picked something that was close. Dying in an aircraft accident. Anybody here scared of flying? So, but again, in this case, we're all riding the same plane now. That's the end. There is a 0.01% chance that we are the last, our generation is the last generation in human civilization. Kind of sobering, huh? I mean, we're talking about losing everything. Everything that human civilization has built up over the last 10,000 years. All the great things, all the wonderful music from the 70s. Bill, that's for you. Stanford, Cal, Cornell. We risk it all. 0.01% chance that we are the last generation. We get reset. Control-Alt-Delete. Okay? Those are the odds. Nobody disputes that. And my question is why? Because it turns out that we actually know how to deflect asteroids. About 10 years ago, myself, a guy named Rusty Schweikart, he was an Apollo 9 astronaut, a guy named Pete Hutt from the Institute for Advanced Study, Clark Chapman from the Southwest Research Institute. We gathered a group of people together with a really tremendous offer. We called up people and said, hey, well, how'd you like to come down to NASA on your own dime and have a weekend meeting to talk about deflecting asteroids? Everyone we asked actually came down. And we started the discussion of what you would do. How would you deflect an asteroid? At the time we were looking at things like nuclear engine, that sort of stuff. Over the years, we realized, along with everybody else, that deflecting asteroids is quite actually straightforward. If you look at an asteroid's orbit around the Earth, and you ask the question, remember, the Earth's a moving target, right? So Earth moves 65,000 miles an hour. If something's going to hit the Earth, if you can delay it from getting to that spot by, remember, the Earth's only 8,000 miles across. That is about 1/8 of an hour. So if you're early or late by 3 or 4 minutes, you miss the Earth, right? All you need to do to prevent an asteroid from hitting the Earth is make it arrive at the collision point 3 minutes early or 3 minutes late. That's if you're a dead square bullseye. Okay? How much of a change in velocity is that? So anybody out here doing orbital mechanics? It's not much. It is tiny. Especially if you are many orbits out and if there are some nonlinear effects, which there are because the solar system has other planets orbiting around in it. Okay? You get amplifications in the effect of small changes in velocity. So it turns out if you look at the sort of average change in velocity you need for a couple of decades ahead of time, it ends up being about 1 millimeter per second. Okay? That's about the speed that an ant walks. Okay? So, take a big rock, 30 years from hitting the Earth, and it's moving around the sun at about, say, orbital speed, 65,000 miles an hour to 100,000 miles an hour. And if you can change its velocity by the speed at which an ant walks, ta-da, you have prevented the impact. Okay? And as long as you can measure the direction that you do this in and so on. But we can. One of the things that NASA has done is shown it's really good at being able to predict where things are and where they're going. Right? We know how to calculate the orbits of things. We know how to calculate their trajectories. We're very good at that. For Christ's sakes, we landed a probe on the shore of a lake of a moon of Saturn. Right? Okay, so these things this is doable. All right? We know how to deflect asteroids.